Hi, this is a quick video about how to factor a trinomial. Some of you have been struggling with this lately, so I thought it would be a good idea to have a little bit of a help video online. Let's focus on this word factor as a start. Sorry about that. Let's focus on this word factor to start. So if we were looking at a number, breaking into factors means that you break it down into a multiplication problem. So if we wanted to find the factors of 48, we'd say, oh, 48 is 6 times 8. And then you could break that down further or factor it further because 6 is 2 times 3 and 8 is 2 times 2 times 2. So factor means you're creating a multiplication problem where there wasn't one previously. So to understand how you factor in algebra, you have to know the opposite process first. As we saw with the number example, the opposite process is multiplication. So first let's think about how we multiply when we're doing an algebra problem. So one thing that we do in an algebra problem is distribute. So in this problem, I distribute the 2x to the x. And 2x times x is 2x squared. So that's 2x squared. And then I would distribute the 2x also to the negative 5. And since 2x times negative 5 is negative 10x, that will be the next term that I write. Then the 3. I need to distribute the 3 to both of those things I just did as well. So I multiply the 3 times the x, and I get 3 times x. And the 3 times the negative 5. And 3 times negative 5 is negative 15. So I would just write that down. Okay, now if you look at this, you can see that there are two terms that will be combined. You also can see where this little memory tool, FOIL, comes from. You take the first term times the first term, and you get 2x squared. You take the outer and the inner. The outer was what gave you the negative 10x. The inner is what gave you the 3x. And then you do the last times the last. That was the 3 times the negative 5. And that's this bit. So this came from first. This came from outer. This came from inner. And the last one came from the last. Okay, so you can see the middle term in one of these problems is going to be the complicated one, because the 2x squared only comes from one place. But these two together merge because you combine like terms. And so this middle term is the one that you really have to do the most thinking about. By the way, when I teach Algebra 1, I say that you do a little face here, that this is Foil Man. Foil Man, he's like a superhero. Not this kind of Foil Man. This kind of FOIL man, okay, when you multiply that out, all right? So when we multiply out two binomials, the outer and the inner are what make this middle term. The first make the first term, the last make the last term. So with that in mind, now let's think about how we go backwards. Okay, so I have a problem like this. I want to say, well, if I had started with a FOIL man problem, this 2x squared comes from first times first. So what times what could equal 2x squared? And we would hopefully come up with 2x times x is what equals 2 times x, right? 2x squared. Then we look in the back. The middle term is complicated. We don't go there next. So the back has 15. I'm not even going to worry about the negative quite yet, okay? 15 could be 1 times 15. It could be 3 times 5. I also can switch the order of those, okay? So let's just start out thinking maybe it's 3 times 5. Maybe I have an idea about that. So let's say I thought that I would put the 5 here and the 3 here. The way that I'm going to check is by doing the nose and the chin of the FOIL man face. Nose and chin. Nose gives me 5 times x. Chin gives me 2 times x times 3. 2 times 3 is 6, and I also have an x. Then I need to ask myself, is there a way to put these two together, depending on pluses or minuses, and get that negative 7x? And there isn't. And so we need to go back to the drawing board, as it were. and undo that, and switch the order, okay? Or maybe it's the 1 and 15, okay? So let's now try putting the 3 here and the 5 here. And I'm going to test that. 3x, 10x. If I put these together, adding or subtracting, is there a way to get negative 7x? There is, if this one were negative and this one were positive, because positive 3 plus negative 10 is negative 7. So this needs to carry the negative because positive 2x here is already positive. And then I need that negative 5 back there. Okay? So 2x times negative 5 would be negative 10. And I need this part to be positive, positive 3x times x. So the signs you're figuring out go with this second part, right? It's not the negatives that go with the part that I have in blue, okay? And so that's how you do it. And that's actually the problem that we started with back here, right? When we just multiplied it out, that's the problem that we did. So we just reversed it. So that should give you the idea that if you want more practice, all you have to do is just make up problems like this, okay? Make up some nice problems with not huge numbers, like don't say 49x plus 17 and 39x minus 42. I mean, don't do that. Just like smallish numbers. Put an x in the beginning of each, right? So have an x type thing here and an x type thing here. Have just a regular number here and a regular number here. Multiply them out using FOIL man. And then put down the answers you get on a different piece of paper. Like make yourself a worksheet. Then you have to go make a sandwich and walk the dog because you don't want to just be remembering what you already made up. You want to see if you can actually factor them. And then come back later and see if you know how to break it down. You'll already have the problems that you used, right? Like here, the reason I had my example is I first did this problem. Then on another sheet of paper, I wrote this. And now it was a factoring problem to see if I could get it back to this state. It's not too hard to make up samples for yourself, okay? But I do suggest that you do things in between so you're not just remembering what you just wrote. One way that factoring gets used, the way I should say that factoring gets used, is to solve equations. So this is the problem that we just did a second ago, except now it says equals 0. Since we know that this factors to 2x plus 3, and x minus 5, we then use the zero product property. If something multiplied by something else equals 0, that means either the first thing has to be 0, whoops, that's 0, or the second thing has to be 0. One of those two has to be the case. There's no other way to get an answer of 0. So if the first one is true, then x equals negative 3 halves. If the second one is true, x equals 5. And I know from that that if I were to graph the parabola that's y equals this, if I were to make a picture of that, it has to cross at 5 and at negative 3 halves, or negative 1.5, on my grid. I don't really know what the rest of it looks like necessarily, but I know those two x-intercepts. I hope this has been helpful. Keep practicing.